analysis. So good morning everybody, and let's start discussing about mesh analysis. Right, so what do you mean by the word mesh? Mesh means it's a loop, right? So mesh is a loop that does not contain any other loop, right? It's a simple loop. Loop means a closed circuit, a closed path. So a mesh is nothing but a loop which is a closed path which is consisting of certain network elements. If a network is large and has large number of voltage sources, it is useful to use mesh analysis, right? What the statement says is when to apply mesh analysis. Mesh analysis is suitable if your network has large number of voltage sources. Right? This is also very important to understand. When should I go for mesh? When should I go for nodal analysis, right? So this statement is going to help you to differentiate when to apply which kind of analysis. So if the network has large number of voltage sources, you go for applying mesh analysis, right? So what are the steps? How do I start applying mesh analysis? So very first step is identify your mesh. Assign a direction to the unknown currents in each mesh. Right, so let us understand these steps with a particular example. Right, so I've shown a small circuit here. Right, so if this is a particular circuit and you have been asked to find the currents and the voltages in this particular network, right, and we see that there are three voltage sources here, right? Every loop, every mesh has a voltage source. Then the best way of analyzing this would be to apply the mesh analysis. So what does step number 1 says? Identify the mesh. Mesh means the loop. So here is a loop, right? There is no other loop inside this. There is no other mesh inside this mesh, right? So this is a first mesh. Right, where do I identify another mesh? This is my another mesh. So I call it to be second mesh or second loop. And then this is my third closed path. I'll call it to be my third loop. Right, so in this way, what I have done first, right, I have identified the loops which are present in my circuit. So there are three loops I have identified, right? And then what it says, what the step says, assign a direction to the unknown current in each mesh. Right, so I'll assign the currents to each loop or each mesh. So let me say that if this is my loop 1, let this current in this loop 1 be I1. So in this way I have even shown the direction. Right, so this is my current I1 in mesh 1. This is current I2. I have assigned a particular direction. Let me say that direction is in a clockwise direction. I have said this is I2, and then I have assigned current I3 in loop 3. Right, so each loop is being assigned a particular current. What does the steps 2 says? Is now the steps 2 says apply KVL to each loop, each mesh. Right, now we'll say let's apply KVL to loop 1. So we'll get some relation of this voltage V1, the current I1 and the resistor R1, R2. Right, similarly we'll apply KVL to second mesh. We'll get some relation between I1, I2 again. We'll apply the KVL to loop 3, and then we'll get some relation between the voltage V3 and the resistors involved in that loop. So this way we'll have three different equations when we have applied KVL to each of the mesh. Right, and all these equations are then to be solved, and that's why step number 3 says solve the simultaneous equations that have been generated by applying your KVL to each of the loop, and then solving those simultaneous equations, get the required voltages and the currents by applying the mesh analysis. Right, so this is what is the concept of mesh analysis. So what is very important thing that we understood is that the best suitable time to apply mesh analysis is when the network consists of large number of voltage sources. Right, if there are large number of current sources, you can go for applying KVL. So the problem is to find the currents I1 and I2. Okay. So when you have been given a particular problem, the very first thing that you need to do is analyze the given circuit. Analyze what are the components present in the circuit. right? So this particular network which is given to us consists of two independent sources of 5 volts and 10 volts. So I have two independent sources, right? Then I have two dependent sources also, right? I have two dependent sources, right? The moment you identify the dependent sources, the next thing that you need to do is identify which type of dependent source it is. So here what I observe is that these two dependent sources are voltage sources, right? They are dependent voltage source. Now the next thing that you do is look at what is being assigned here, right? So it is, this dependent source is a function of Ix. It means that it is a current controlled voltage source, right? Similarly, what about this? There is 2Iy. So this particular voltage source is also current controlled voltage source. So this is the way you identify the type of the sources which are given in your network, right? So this particular voltage source is dependent on current Ix. This particular voltage source is dependent on current Iy, and that's why in your network even Ix and Iy are clearly mentioned, right? Because if this is a function of Ix, the network should consist of where is Ix. So Ix is here, and there is Iy. Iy flows through the 4 ohm resistor. So all the details are given to us in the network, and the problem says that you find the currents I1 and I2. Right? So what is the very first step we need to do? As per, if we are going to apply mesh analysis, what is the very first thing that we need to do? The very first thing that we need to do is identify the loops, right? The first thing that we need to do is identify the mesh or identify the number of loops. So how many are the number of loops here? There are two loops. This is my first loop and this is my second loop. So there are two loops in this particular network. So we identified the loops, we named them that this is my loop 1, this is my loop 2. Currents are already given to us, so the current, the next step was to assign the current. So currents are already mentioned that this particular loop has current I1, this particular loop has current I2, right? So currents are mentioned, the loops are identified. The next step is to identify the KVL. But before we go to KVL, since we have dependent sources, let us analyze the dependent sources first and then we'll apply the KVL. Now what do we understand? We will assign those dependent sources, right, with the values of the currents that we have used in the network. So what is my Iy? Iy is nothing but I1 because I have assigned the current in this loop as I1. So Iy is nothing but I1, and that's what we did first. Before we start to apply the KVL, we said that Iy is nothing but I1. What about Ix? The direction of the current of Ix is this, right? So now in this particular branch, right, there are two currents which are flowing. It is I1 also and there is I2 also. Now whether Ix should be I1 minus I2 or whether it should be I2 minus I1, who decides that? It is decided by the direction of the arrow, right? So here they are particularly mentioned as that the current flows in this particular direction, right? So following this direction of the current Ix mentioned in the network, we now say that Ix must be I1 minus I2, right? This is what you should clearly understand, right? Ix must be I1 minus I2. Right, so now I know what is my Iy and what is my Ix. I have you could say assigned Iy and Ix to my network currents I1 and I2 because there will be lot many variables. If I use I1 also, if I use Iy also, many unknown variables will be there. That will make the equation complicated. So let us use the network currents that we are going to that we have assigned, and then use those minimum current elements so that the equation becomes simplified. So wherever there is Iy, we'll be using I1. Wherever there is Ix, we'll be using I2. I1 minus I2. So with this, now we'll start to apply KVL. So let us apply KVL to mesh 1. Right. So everybody Just think, how would you apply, what would be your equation for mesh 1? Right? Following the current direction, what would be the equation for mesh 1? Right? So you follow and you choose any point where you will start applying your KVL, follow that, and following the reference point, you go in a clockwise direction following the current direction that you have assigned and complete the KVL equation. Yesterday we have also discussed the rise in the voltage, the fall in the voltage, that helps us to assign the polarities of the voltages that we are going to consider when we apply KVL. So KVL says that sum of all the voltages in a closed circuit is 0. Right? This is what is KVL. So pick any starting point. Right? Let me say I start applying. I hope that you have finished formulating the mesh equation. So verify it with me now. So let us say the starting point is this particular voltage. Right, so I'm following the direction of the current which is assigned in this particular loop. So looking at the polarity of this voltage, we are going from positive, we are starting from negative point terminal to coming to positive. Definitely this is the fall in the voltage, right? And it has to be considered minus since we are starting with the negative terminal. So it is minus 5. Then it is, I'm following in this current direction. So what is the current here? I1. So I1 minus I1 into 5. So minus 5 minus I1 into 5. Then I come to the dependent source, right? So what is the voltage of this? The voltage of this is 2Ix, right? So how would I do that? It will be look at the terminals, look at the polarities of your dependent source. It is plus to minus, so definitely it is going to be minus. So minus 2Ix. Then I come to the register, it will be minus 4. What is the current here? I1 minus 4I1. Now I come to the 1 ohm resistor. What is the current in this branch? It is I1 minus I2. So minus bracket I1 minus I2. Then I come to the next dependent source. Now look at the polarity here. The polarity here is minus to plus. So I have to add this particular voltage. This is rise in the voltage, right? So plus 2Iy is equal to 0, right? So see how your mesh equation is turning out to be. So I have shown it here. Verify it now. So we started with minus 5, correct? This minus 5. Then we took minus 5I1, which is shown here, minus 5I1. Then we came to the dependent source. The polarity is plus minus. So again it is fall in the voltage. So it should be minus 2Ix. Then the 4 ohm resistor with current I1 flowing through it becomes minus 4I1. Then this 1 ohm resistor in which there are two currents which are flowing. So it is minus I1 minus I2. And then this second dependent source with the polarity minus and plus, and that's why it is added, plus 2Iy is equal to 0. Right? If you are correctly formulating this equation, then you have applied KVL correctly, you have understood KVL correctly. Right? So what is important is the sign, right? The signs that you have assigned. If you make a mistake in that, then your equation is wrong, your further values will be wrong. So what is important is the polarities when you are formulating the equation. I hope this is clear to you, right? And now what we do is simply substitute what is our Ix, what is our Iy. So what was Ix? Ix we have already said is I1 minus I2. So we substituted Ix as I1 minus I2. What is our Iy? Iy is I1. So we substituted Iy as I1, and we need to simplify this, collect the similar terms, collect I1 terms, collect I2 terms, and then we get the equation which is this, right? So you can solve it I hope you even might have done it also. So this is the equation that we get. There are two unknown variables here, I1 and I2, and I call this to be my first simultaneous equation. Let me name the equation as equation 1. So we applied successfully KVL to loop 1 or mesh 1. Now we will do similar analysis for mesh 2. Right, so we'll now apply KVL to mesh 2. Right, so this is our mesh 2, loop 2. Right, so the direction of the current is in this direction. So choose any starting point and start to apply the KVL. So if I say let this be my starting point, right? So look in what direction the current is flowing. The current is flowing in this direction. So there is a fall in the voltage. So minus 2, right? The polarity becomes minus 2. What is the current? Current is only I2. So minus 2 I2. When I come into this particular when I come to this particular terminal, right, it is plus 2 minus again, and that's why I consider it to be a minus 2 IY. When I come to this 1 ohm resistor now, right, what are the currents which are flowing? It is I1 and I2 both. Whether it will be I1 minus I2 or I2 minus I1, now it should be I2 minus I1, because the primary current of this particular mesh is I2, right? Secondary current is I1, so that's why it becomes I2 minus I1. So this completes your particular mesh equation and you verify it, right? So what do you get? Right, so just check it, apply your whatever you have applied KVL, you check it now. Let us start with minus the voltage at this particular point. So minus 10. When we come down to this, as we are moving from plus to minus, it becomes a fall in the voltage. So it is minus 2 IY. When I come to 1 ohm resistor, right, it will be I2 minus I1. So minus of I2 minus I1, and then lastly the current through 2 ohm resistor, which is minus 2 I2 is equal to 0, right? So this is how you formulate your KVL equation. This is important, friends, right? This, if you do this correctly, then there will not be any mistake in solving the problems, right? And then finally what we do here, we know that our IY is nothing but I1, right? So we substitute it and we get one more simultaneous equation, which turns out to be minus I1 minus 3I2 is equal to 10. So you have two simultaneous equations, equation 1 and equation 2. I hope you all know how to solve simultaneous equations. So apply simultaneous equations, right? Solve it, simplify it, and the currents that you get in this case is I1 is minus 1.364 and I2 is equal to minus 2.878. Okay, so if you have time, you can verify it now, or later you can check your answers. Right, so from this I1, I2, I get my IY, which was nothing but I1, which is the value of I1. IX was I1 minus I2, and accordingly I get my I1 minus I2. Right, so this is how we have applied KVL to a particular problem. Let us move on to one more problem. Okay, so there is, now the question says, find the currents in the three meshes. They have not mentioned the currents. The question says, find the currents in the three meshes. So this is a new network given to us and we have been asked to find the currents in the three meshes. Right. So what is the very first thing that we do? Following the steps as we had just said, we have to identify the meshes. So we have three mesh here, 1, 2 and 3. We have three mesh. So once we identify the mesh, what is the next thing that we do when we are doing mesh analysis is to apply the currents, assign the currents. So we'll assign the currents in this particular mesh as I1. We'll assign the current in this particular mesh as I2 and this as I3. So we have assigned the currents I1, I2, I3. Now before we proceed and apply KVL to each of the mesh, as I just said, analyze your circuit. Analyze what all are the type of sources given to you in the network. So when I closely analyze my circuit, the first thing that I understand is I have given one independent source which is 5 volt, another independent current source which is 1 ampere. So I have two independent sources. One is voltage source, another is current source. Along with that, the circuit also consists of two independent sources. I have two independent sources. Now, what are these independent sources? Whether it is a current source or a voltage source. So, this symbol indicates it's a voltage source, right? So, they are independent voltage sources. Now, look at what is assigned with this particular voltage source. So, there is an Ix assigned to this, which indicates that this is a current controlled voltage source. Similarly, there is Iy associated with this source, which indicates that this is also a current controlled voltage source. So both are current controlled voltage source. Now what is Iy? Now our Ix and Iy must be mentioned in the network, right? Because the definition of independent source is that they are dependent on some current or some voltage in the network. So Ix must be some current which is present in the network. Iy must be some current which is present in the network. And hence in the network, if you see, this Ix is mentioned here, which is nothing but the current which is flowing through 1 ohm resistor. What is Iy? Iy is another current which is flowing through this parallel resistor 1 of 1 ohms. So Ix and Iy are clearly mentioned in the network. Right, so this current which is flowing through 1 ohm resistor. So can I find some equation of Iy which is dependent on my network currents which we have assigned as I1, I2, I3? Definitely. So Iy is the current which is flowing through 1 ohm resistor. Look at the direction of the way Iy is mentioned and then formulate the current for Iy. So in this particular branch, the two currents which are flowing are I2 and I3. So using I2 and I3, we can get the equation for Iy. So with the direction mentioned Iy, the equation of Iy comes out to be I2 minus I3, because I2 is in the direction of Iy. Right, and that's why Iy equation turns out to be I2 minus I3. Similarly, formulate some equation for Ix in terms of I1, I2, I3. What it could be? Yes, here Ix is the current which is flowing through 1 ohm resistor. The only current which is flowing through 1 ohm resistor is I1, and hence Ix is only a function of I1. So nothing but Ix is I1. Right, so we got Ix, we got Iy. Now look at this particular loop. What is I3? I3 is the current which is flowing through this particular branch. So I3 is flowing through this particular branch which is having only a single current source. It means that this I3 must be equivalent to the current source which is present in this particular branch. But look at the direction. I3 is flowing in a direction which is downward direction, whereas the current source has the direction which is in the upward direction, and hence because of the arrow mentioned in the current source, we have to assign I3 to a value of -1, since both are in the reverse direction. So I3 directly is found from the value which is the current in this particular branch which has a current source in it. I3 turns out to be equivalent to the current source in that branch, and there is a minus sign because the currents are in the reverse direction. So I3 is minus I1. So once you do this particular analysis, right, because this helps you to solve the simultaneous equations, right? You have minimum variables now. You have everything in terms of I1, I2, I3. There is no Ix, Iy now. Everything is in the form of I1, I2, I3, and we even have a value of current already found to us, which is I3 is -1, right? So this simplifies the things before you actually start to apply the KVL. Right, now start with applying KVL to your mesh 1, loop 1. Right, so how is the KVL? How is the equation? So start from any point. Let us say we start from 5 volts, the independent current source, voltage source. So if this is the point, then as we are moving from positive terminal to negative terminal, this has to be considered positive. So 5 minus 1 into the current which is flowing in that branch is I1. So 5 minus I1. When I come to this particular voltage source, what is the voltage here? It is IY. What is the polarity? Plus minus, right? So it will be minus IY. When I come to this particular register, what are the minus? Here I said it is minus IY. Instead of IY, what we could say? It is minus I1 minus I2, because IY is nothing but I1 minus I2, right? So here I am following this particular direction. So here the current is nothing but I1 minus I2, and then I come to 1 ohm, right? So what is the current through 1 ohm resistor again? I1 minus I2, and then my loop equation is equated to 0, right? So when I formulate my equation, what is it I have got? So you verify now. So you started with 5, then there is minus I1, which is nothing but the current through 1 ohm resistor. It is minus IY, and then there is minus the current through 1 ohm resistor, I1 minus I2, and then equated to 0. And what we did in the next step, we substituted IY was nothing but I2 minus I3, that we have already seen, right? Done in the first step. So in this way, if we do, what is the thing that we got? We got it that I1 turns out to be 2 amperes when we solve, because I3 is already known to us. So if I3 value is known, right? So when we put here I3, we get the variable as I1, I2 gets cancelled here, so I1 turns out to be 2 amperes, right? So solve the equations to get the required values. Now let us move on to applying to mesh 2. So let us apply to mesh 2. So what do you understand now in mesh 2? Choose any starting point. Let us say we'll start here. What is the current through 1 ohm resistor? It is I2. So start formulating here. So minus I2. When we come to this particular voltage source, what is the value of this voltage source? Is Ix. So minus I2 minus Ix. When I come to this particular branch, what is the current in this branch? I2 minus I3, because primary current is I2, secondary current is I3, because we are in loop 2. So it will be I2 minus I3. When I come to this particular register, what is the current here? It will be I2 minus I1, because we are in loop 2, primary current is I2. So I2 minus I1. When I come to this particular dependent voltage source, what is the voltage source and what is the polarity? It is minus to plus. So it means that I have to add this. It's a rise in the potential. So I have to add it. Plus Iy is equal to 0. Right? So minutely look at the polarities, minutely look at the currents which are involved in the loops, and then frame your equation, right? So you don't make the mistake. So if I just verify it here, so what is the equation we have obtained? So let us start. So minus I2 means I am talking about the current through 1 ohm resistor is minus I2. The next is the voltage source, so it is minus Ix. When I come to this 1 ohm resistor, what is the current here? It is I2 minus I3, so minus I2 minus I3. Then we come to this 1 ohm resistor, what is the current there? Here it is I2 minus I1, so it is minus of I2 minus I1. And when we come to the last voltage source here, the polarity is minus to plus, and then therefore it is rise in the voltage. I have to consider it to be plus Iy is equal to 0. Right? So this is the KVL equation we have obtained. Now what is the next thing we have to do? Replace your Ix and Iy in the variables I1, I2, I3 that you have formulated. So we know that Ix is I1. So we replaced Ix by I1. We know Iy is nothing but I2 minus I3. So we replaced Iy by I2 minus I3. I3 is already known to us. I1 is also already known to us in the previous KVL loop, and hence we get I2 to be, when we solve this particular loop, we get I2 to be 0. So this